Hello, 8th graders. We are doing Module 4, Problem Set 13 for Lesson 13. First problem, it states to find at least 10 solutions to the linear equation 1 half x plus y equals 5. Then plot the points on the coordinate plane, and then once you do that, you have to decide what shape is the graph of the linear equation taking. I'm changing this just to save time. We're going to find 6 solutions. I know they're saying in the lesson, the more you do, the more you can see the consistency, if there's consistency. But we are just going to be doing 6 to save time. So I'm going to do our, like we did yesterday, our chart, our X and our Y. And we have 1 half X plus Y equals 5. And we have to decide, are we going to pick our X and find out the Y, or are we going to pick Y and find out the X? Looking at our X and Y here, X has a coefficient, so we would actually choose X's. That would be the easiest way to do it. And because this is a fraction, we want to take multiples of our denominator. Our denominators is 2, so we're going to take multiples of 2. So we're going to go 2, 4, 6, 8, 10, 12, okay? So let's start with 2. So we got to take our 2 and put it in for X. So we have 1 half times 2 plus Y equals 5. So I'm going to do this over here on a separate piece of paper. We have 1 half times, and I'm going to make this 2 over 1 plus Y equals 5. So this is going to be, remember to multiply fractions, we must multiply across. 2 over 2 plus Y equals 5. That's going to be 1, because 2 over 2 is 1, plus Y equals 5. To solve this, we're going to subtract 1 from each side. And we get Y equals 4. So our Y is going to be 4. And our ordered pair is going to be 2, 4. And that's what we'd use this ordered pair when we graph. Let's go on to the next one. First we chose 2. Now let's take 4, because 4 is another multiple of 2. So once again, we're going to have to put 4 in for X. We'll have 1 half times 4 plus Y equals 5. So I'm going to do this, rewrite it down here, 1 half. And I'm going to make this 4 over 1, so we can do our multiplication, plus Y equals 5. 4 times 4 is 1. 2 times 1 is 2. So 4 over 2 plus Y equals 5. 4 divided by 2 is 2, plus Y equals 5. Now we're going to have to subtract 2 from both sides. And we get Y equals 3. So Y is going to be 3. And our ordered pair is going to be 4, 3. X is 4, Y is 3. Now let's go on and we did 2, 4, let's do 6. So we're going to have to put 1 half times 6 plus Y equals 5. So let me do this here. I have 1 half. I'm going to write 6 as 6 over 1 plus Y equals 5. This is going to end up being 6 over 2 when we multiply across, plus Y equals 5. 6 divided by 2 is 3, plus Y equals 5. subtract 3 from both sides, and we get y equals 2. So when x is 6, y is 2, and our coordinate pair is 6, 2. So we did 2, 4, 6. Let's do 8. So we're going to do 1/2, put in 8 for x, plus y equals 5. You're going to write it as 1/2 times 8 over 1 plus y equals 5. This is going to be 8 over 2 when we multiply across, plus y equals 5. 8 divided by 2 is 4. 4 plus y equals 5. I'm going to subtract 4 from both sides. You get y equals 1. When x is 8, y will be 1. And we will have 8, 1 for our ordered pair. Okay, let's do 10. So we're going to have to do 1/2. 10, put 10 where the x is, plus y equals 5. So I'm doing this on a scrap piece of paper. 1/2 times, I'm going to write this 10 over 1 so we can multiply it, plus y equals 5. When we multiply this across, we get 10 over 2 plus y equals 5. 10 divided by 10 is 5, so 5 plus y equals 5. Divide both sides, subtract 5 from both sides, and we get y equals 0. So y is going to be 0 when x is 10, y is 0, our coordinate point is 10, 0. And the last one we're going to do today is going to be 12. So we're going to go 1/2 times 12 plus y equals 5. So we'd write this 1/2 times 12 over 1 plus y equals 5. This would end up being 12 over 2 plus y equals 5. 12 divided by 2 is 6 plus y equals 5. I now have to subtract 6 on both sides, and y is going to equal -1. So this is going to be -1 here when x is 12, y is -1. We're going to have 12, -1 for our coordinate points. Now we're going to have to graph these coordinate points. So I'm going to go over to Clever. Let me shrink this up a bit. I'm going to open up our GeoGebra. And I'm going to start graphing. Pick the two shapes, and I'm going to graph points. My first point is 2, 4, so 2, 4. My next point is 4, 3, so across 4, up 3, 6, 2, across 6, up 2, 8, 1, so I'm going to cross 8, up 1. I'm going to put this over to move, so I can move this over a bit, do some more points. 10, 0, go 10, up 0, and 12, -1. And we graph these like it asked. Now it says, what shape is this linear equation? Well, we can look and we can see that, hold on, that this is a line. This forms a straight line. So what shape is the graph? It's a straight line. Remember, we've talked before, linear equations. What word do we hear in linear? Line. So linear equations form a straight line. The next few questions are just asking if these points, can the following points be the graph of this equation? So if we have x minus y equals 0. First, is this a linear equation? Remember, if you have an exponent of a variable or a variable in a denominator, it's nonlinear. We don't have any of those. So this is a linear equation. So I'm going to write here, is a linear equation. So let's connect these points. Does that create a straight line? So the equation is a linear equation, but the line is not a straight line. Therefore, this line, the points, are not a graph of the equation. Points are not a graph of the equation. Okay, because we know this has to be a straight line, it's a linear equation. This is not a straight line, therefore this cannot be the graph of that. Let's look at the next problem, problem number 3. Once again, is this a linear equation? Yes. So it is a linear equation. Now let's connect our points. We have a point here, a point here, point here. Is this a straight line? Okay, so not a straight line. Therefore, this is not a graph of the equation because the graph of this equation has to be a straight line. Therefore, not a graph of the equation. Okay, let's go on to number 4. Let's look at our equation. It is a linear equation, so yes, it's a linear equation. Now let's connect our points. Is the graph the straight line? Okay. Yes. Graph is a straight line. Therefore, the graph can be a graph of the equation. It's a linear equation. This is a line, so this could be the graph for that. Number 5. Is this a linear equation? I don't see exponents to the variables. I don't see any variables and denominators. So it's a linear equation. Let's connect the points to see if they form a straight line. Okay, so yes, the graph is a straight line. Therefore, this can be a graph of the equation. Let's go on to 6. Let's look at the equation. Is this the linear equation? Yep, so we have a linear equation, which means the graph of it would have to be a straight line. So let's connect our points. So the graph forms a straight line. Therefore, this can be a graph of the equation. And our last one, number 7. Is this a linear equation? Yes, it is. It's a linear equation. So let's connect our points. We have a point here, 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 and a point here. So is this a straight line? It's not a straight line. Therefore, this cannot be a graph of the equation. So I hope you're understanding that when we have linear equations, their graph must be a straight line. If it is not a straight line, it's not going to be a graph to a linear equation. Have a good day.